Now, this segment of the Goals of Software Design topic looks at software modifiability. All successful software gets changed. If you have users at all, they'll want changes and improvements. Also, modern software practice concentrates on producing the minimum viable product, which is the simplest and smallest set of features that will satisfy at least a modest set of users. And then we add features based on user response to that product. And such a strategy is built on the assumption of incremental modification of the software. Even if your users are content, you still have to deal with adapting to new hardware, changes to any third-party supplied software libraries that you used, changed government regulations, new features that your product, that your competition adds and that you have to match, and of course, last but not least, changes that you have to make to fix bugs discovered after you released the product. And the desired modifications are very difficult to predict. It's notoriously hard to know what users will request in the way of new features. Even asking them in advance, such as by market surveys and focus groups, still produces pretty inaccurate results. What users think they want when discussing a potential product via a storyboard mock-up turns out to be rather different from what they actually want once they work with the live software. In fact, the minimum viable product strategy is built on the assumption that you will not know what features are truly important until the software is in use. So you may as well get a bare bones version out the door as fast as possible and improve it from there. If you can anticipate future government regulation changes or know for sure what your competition will do, you're doing better than the rest of us. And if you know what bugs will arise and require changes, well, then you should have fixed them in the first place. Now let's add to the fact that software is hard to modify. Like other large software phenomena we've discussed, this isn't always obvious at the 1,000-line level. If you're modifying a 500-line class in a 1,000-line program, there are only 500 other lines of code that might be unexpectedly affected by your changes. But in a 1,000,000-line program, there are 999,500 other such lines. So without careful planning, the chance of an unexpected side effect of your change is almost 2,000 times as large. Looking at this another way, the number of different pairs of lines, potential interactions between lines of code, goes up by the square of the number of lines overall. It's very easy for a change in one part of a large system to affect many other parts of the system. Now, a good design avoids this problem by concentrating each particular part of the program's behavior into one class or module with a well-defined interface, a set of function calls and parameters, or an object-oriented interface, and so forth. If a module's interface is defined well enough, and if the rest of the code uses the module only via that interface, then the module can be changed without side effects. And if every part of the program uses the same module to do a particular task, then there aren't multiple places in the code needing change. If a diagramming program, for instance, has many different places in the program where color choices are made, with each different part of the program sporting its own color choosing logic, then a change to the color choosing system will require modifying and testing all those portions of the code. But if a single color chooser class performs this function whenever needed, and if the rest of the program uses the color chooser class through a well-defined interface, then the modification will require only a change to color chooser. Good design anticipates likely changes to the software and breaks the software into modules or classes that can be independently modified, like the color chooser class. Doing so involves complexity costs, however. There is thus a tension in design between trying to generalize everything in anticipation of all possible modifications and incurring the cost of a lot of elaborate abstractions, or on the other hand, building simple solutions without regard for future changes and incurring the cost of having to change far more code on each modification. Here's an example for you. Any program that will be used internationally cannot simply hard code strings that the user will see. If a program is greeting the user, it can't just print hello. It will need to print hello for an English user, hola for a Spanish one, and ni hao for a Chinese one. This process of choosing the right string for a given locale is called string localization. Now, the standard design for this problem is to build a class for localization. Let's call ours string localizer. And a Java implementation might look like this. We've got our string localizer class, and it has a public enum listing every string in the program, string choice, and then a string localizer.location enum that lists every possible location. Now, at the start of the program, we construct a string localizer class, and we give it a location. And we'll call our object stir localizer, and it has, as I say, a specific locale. Now, if we're running the program in China, that might be, for instance, new string localizer location.china. Our string localizer object looks up the strings for China and loads them into a table. And a string can be fetched from the table by calling getLocalString with the right enum value. We make string localizer available to any part of the program that needs to print strings. So code like print hello becomes instead print, think through this carefully here, stir localizer.getLocalString, and passing it stringChoice.hello message. And then to make that statement work even in English does require adding a new enum value for the hello string and putting a new entry in the English language table. Is this complex? You bet it is. Maintaining an enumeration system for strings and locations, setting up string tables, consulting a string localizer every time you need a string, it's all pretty tedious, and it adds a lot to complexity cost. And also, testing the software is correspondingly more complex. It's not enough for it to work right in English. You need to check it in other languages too to be sure there aren't any places where a sloppy programmer just used a direct string instead of consulting the string localizer. That's actually a very common problem with such systems. Now, if you need to adjust the program for different languages, that cost is totally worthwhile. Adding, say, French requires only adding another location enumeration and a table of strings in French. Only the string localizer changes, and the thousands of lines of code using strings aren't altered at all. The opposite is unthinkable. With hard-coded strings, you'd have to modify every line of the program that uses a string and maintain completely different program versions for different languages. But if you never actually use the program overseas, the entire cost is wasted. Now, you could start with the simple direct-coded version and then retrofit it to use a string localizer later when you decide to localize the program. But updating a program that has not planned for string localization involves going through the entire codebase and finding every hard-coded string in the code, at least those visible to the user, and replacing it with a call to a string localizer class. Now, this is soul-crushingly dull and tedious, as the many software developers who've had to do it can testify. It's much cheaper to install the string localizer from the get-go. At least it is if you actually end up needing it. Now, this sort of trade-off is what keeps software designers up at night, and it arises all the time. Do we do the more modifiable but more complex design or not? Will we end up needing it in future modifications, or will it turn into a white elephant that's completely wasted? Making these sorts of design trade-offs between generalizing a design and keeping it simple is one of the most important judgment calls in software design.